Okay, so this lesson we're going to be talking about colligative properties. So before I get into that, we're going to go over what vapor pressure is. And then I'm going to come back and go over colligative properties because it's kind of intertwined. It's important. So vapor pressure is the pressure exerted by a gas above a liquid. So what that means is, let's do this. Draw a little beaker. So our beaker, we're going to cap it off. We're going to pretend like it's just capped. So inside, in the liquid, we have our liquid phase stuff. And then, see, we had a volatile liquid. We have all these gas bubbles on top. So the red indicates we have gas, and the blue is the liquid. So it's essentially when you have something that's volatile, that means that it's going to boil off. So volatile liquids are liquids that readily evaporate. Which means that they have a low boiling point. So, low boiling point, not low boiling. So they have a low boiling point. That indicates, so when you have a low boiling point, that indicates you have weak intermolecular forces. Alright, so if you had vapor pressure, and you have your IMF, if your vapor pressure is going up, your intermolecular forces are going down. Vice versa, the vapor pressure has gone down, that means your intermolecular forces have gone up. So intermolecular forces are why water with such a small mass takes so much energy to cause it to boil. So let me give you an example. Say we had, I'm going to write down the names first. So we have ethane, and we have ethanol. So ethane is CC and a bunch of H's. Ethanol is an alcohol because of the OH group on it. When I say OH group, I'm talking about this right there. So ethane only has dispersion. Ethanol has dispersion, dipole-dipole, and it's got hydrogen bonding, which was super strong for covalence. So if you had to guess, which one would have the higher vapor pressure? Pause the video and guess. Alright, so your higher vapor pressure would be this one right here. Because it only has one really weak intermolecular force. This one has a lower vapor pressure. And that's due to the stronger intermolecular forces. So that means this one has weak IMFs. This one has strong intermolecular forces. So that's really all I wanted to talk to you about vapor pressure in terms of theory. It's not too complicated. But now we're going to go into colligative properties. So I'm going to write down the definition of this. Alright, so you have colligative properties. So, properties of all solutions depend on the number of particles dissolved. Not the identity of the solute. Okay, so let me see if I can find the picture that I was going to put in here. I don't even know if you guys will get the reference, but maybe it's nope. I don't even know if I have it anymore. Yeah, I must not have it. Anyways, so I had a cool picture I was gonna put in there, but anyways. Alright, so electrolytes. Electrolytes, I'm gonna write down a bunch of definitions. You guys should probably know these. So electrolytes are soluble ionic compounds. So batteries function with electrolytes, and we have if you think about like whenever you see sports drinks and they're like, oh, you need to replenish your electrolytes, usually what they're talking about is potassium, because of the sodium potassium pump in your cells that I'm sure you probably learned about and forgot from biology. Anyways, so electrolytes are super important in chemistry. Now, something we need to be aware of. We have the Van Hoff factor. So, Van Hoff factor is represented by I. So, I know in math I is for imaginary numbers. In chemistry it means the Van Hoff factor. So, there's two ways it's represented. You have ionic compounds, and we have covalent compounds. So, in ionic compounds, the Van Hoff factor is the number of ions in solution. In covalent compounds, I equals 1. And this is always. So let me give you an example for, I'm going to do it in the green. So we have, here's an example for ionic. Al2 SO4 3. So if you split this up, you have 2Al plus 3 plus 3 SO4, which is negative 2. You have sulfate and aluminum. So that means you have 2 moles plus 3 moles equals 5. So that 5 is what your I is equal. That's the number of ions you have in solution. So let's circle that so you can see that. And it's pretty simple, but you're going to have to do that for a lot of equations. I know we're talking about gases, but this also jumps kind of back and forth between solutions and gases. So, now we're going to go on and talk about Raoult's Law. So Raoult's Law states that the pressure of a solution is equal to the mole fraction of the solvent times the pressure of the pure solvent. So let's write these definitions down first, and then we're going to go into important variables. Then we'll go into an example, and then that should take us right up to the end, because colligative properties is kind of a long series of notes. It's a lot of math, so I want to make sure that I'm not going too fast, and we're going to do a lot of practice problems. Anyways, so important variables or / definitions. So we have vapor pressure, which we just talked about. So the pressure of the vapor over a liquid at equilibrium. So equilibrium just means it's good. It's not changing. It's kind of going back and forth, but it is good. So you have non-volatile solutes, meaning it's going to dissolve. So will lower the vapor pressure of a solvent. And then we have the P of the solution, which we've already said. Observed pressure of the solution. And then we have X solvent. That is mole fraction. The mole fraction of the solvent. And we have one more, which is, what is the equation for this? So we have moles solvent divided by moles solvent plus moles solute. Okay, so this all probably is a lot of information. I would suggest pausing and making sure you write everything, and then making notes of where it is. So we're going to go on to an example for Raoult's Law, and then we might get to osmotic pressure for this video, maybe not, because I'm going to try and take this pretty slow to make sure you guys get it. Alright, so, and then P solvent, this is the last one, last definition, the vapor pressure of the pure solvent. Okay, so I'm going to give you a picture, and then we're going to write down the question. So I'm just drawing my little liquid real quick. Okay, there's my liquid, and then we'll put some stuff in there. Alright, there's stuff in there. Alright, so we have a solution of water that is 0.7 liters in volume. And we add 200 grams of sucrose to it. What is the vapor pressure afterwards? So to figure this out, we first have to know the starting vapor pressure. So the starting vapor pressure of pure water is going to be about 23.76 torr. All right, so that's for, let's write that down. The P of the degrees equals 23.76 torr. Okay, so now we need to calculate the moles of sucrose that we have and the moles of water that we have. So H2O equals 18 grams per mole, and we have 0.7 liters. Sucrose is C12H2022, and then it's O11. And to save us all time, I've already calculated it. It's 342.3 grams per mole. And we have 200 grams of it. So we have, if you remember the density thing, first let's convert this to milliliters. So we have 700 milliliters of water. So water has a density of 1 gram over 1 milliliter, which is why we converted it. So we actually have 700 grams of H2O. So we have all the information we need to convert this into moles. So first step is, actually there is no real first step. I'm going to do it this way. We're going to calculate the moles of our solute, which is sucrose. So we have 200 grams times 1 mole over 342.3 grams. So that is 0.584. Okay, so then let's calculate the moles of water, which is the moles of our solution. So we have 700 grams times 1 mole over 18 grams. So let's do this in the calculator. We have 700 essentially divided by 18. So we have about 38.9 moles of H2O. So now that we have this information, we have to calculate the mole fraction of the solvent. So that would be X. So that means our solution is X solvent. So we have 38.9 moles, and then that's over 38.9 moles plus 0.584 moles. So let's plug that in the calculator. So we have 38.9 divided by 38.9 plus 0.584. And then that's going to give us 0.985. So roughly 0.985. So let's plug this in to figure out what the P solution is, because that's ultimately what we're trying to figure out. So this equals X solution times vapor pressure. So the vapor pressure is what we started with, and then the X solution is this. So we have P solution equals 0.985 times 23.76 torr. And then all you got to do is just multiply it, and that's going to give you your answer. So times 23.76, and you should get about 23.41. So your answer roughly for P solution is 23.41 torr. So adding just a little bit of sucrose does take the actual vapor pressure and lower it, which is what this law is showing you. So this would be your final answer right here. So another thing that you could do with this is, say I wanted this converted to atmospheres, you could see like how little of a difference it makes too. So you have 23.41 times 1 atmosphere divided by 760. Because it's such a small amount, it's almost negligible if you use atmospheres. So equals 0.0308 atmospheres. And if you take the original, which was 23.76 times 1 ATM 760, that's going to give you, and you don't have to do this, I'm just showing you for GWiz info, 0.0312. So honestly, like most of the times you'd be rounding at like the 3.1 mark. So that's why we're using torr, because torr and millimeters of mercury are a little more sensitive in that regard. Alright, so we're going to stop here for today, because if I go into osmotic pressure, that's going to be like another 20 minutes. And I want to make sure that we have enough time to practice some more problems. So probably next week we're going to be doing some more problems. I'm going to give you some practice to do this week. You have a quiz that is based on gas laws. And then next week you're going to have a test based on gas laws and some of the colligative properties. It's either going to be a test or another quiz, and then I'll do a test the week after for the whole unit. I'm probably going to split it up. But anyways, if you have any questions, come to my office hours or email me. And if you email me, make sure you're just sending me, you have to send me an image or tell me which number it is, because I don't know. If you're coming to the office hours, like I've said before, please come with an image and upload it into the chat when you're in there so I can just quickly work on it.